This is the highest spinning wedge I've ever hit that's legal. It's coated with 2 carats of diamonds. Hi, my name is Patric Lager, and I have built and refurbished golf clubs my whole life. I refurbish golf clubs for fun, as an expression of art, and as my therapy. I'm also interested in new and unique innovations when it comes to club making. From this, the idea was born to video document innovations that I find and believe in a series of videos. I've had the pleasure of getting to know Michael Feldstein, president of Surface Technology, Inc. Surface Technology is an innovative leader in the metal finishing industry for many industrial applications, and specifically has created an Electroless composite diamond coating technology that I think is revolutionary for the golf industry. I've tested it and find it far superior to any club finish I have tried, and I have tested a lot of clubs and technologies over 50 years. The physics of diamond coated clubs is easy to understand. When striking a golf ball, some energy transforms to heat and some energy is absorbed by the club. Titanium or steel transfers about 65% of the club's energy to the ball. A club that is coated with diamonds absorbs less energy and hence transfers more energy to the ball at impact. In fact, independent robotic testing of this composite diamond coating proved an increase in ball distance over 7%. Another significant advantage of diamond coating relates to wedges. A new golf wedge spins a ball about 9,000 RPMs, which declines by up to 25% after use. I've hit my diamond coated wedge hundreds of times, and under a microscope, there's no visible wear due to its face hardness. So without further ado, let me show you how I coated my clubs with diamonds. Michael, thank you so much for having me today. A brief overview. What is Surface Technology, Inc.?
Well, first, Patrick, welcome to Surface Technology. It's great to have you here in our facility. We're very proud of what we do here. We're very unique in our industry. We make a lot of specialty coatings, and they can have properties for hardness and wear resistance and corrosion resistance, high and low friction, release properties, heat transfer. We make these synergistic composite coatings.
A significant factor for spin is the surface roughness of the club face, which is regulated by the USGA. Can you talk a little bit about the roughness of your composite diamond coating technology and your interaction with the USGA?
I'm really glad that you asked the question and referred to composite diamond coating as a technology, because it is a family of technologies that can create multiple products, and the products can be varied by a lot of specific parameters that we can change to affect the thickness of the coating, the roughness of the coating, all sorts of other areas, to then yield a product that is best for a specific application. In the case of golf clubs, it's an ideal coating for golf clubs because it conforms perfectly to the shape of the club. It conforms perfectly to the grooves. It won't add buildup. It won't distort the shape of the grooves. And then the specific level of roughness, we can adjust that by adjusting the diamond that we're using within the coating. And it's genuine diamond that is in each golf club and the coating that's being applied, and by adjusting that you'll have a different level of roughness, and it can be exactly consistent and maintained over time. And fortunately, through our interaction with the USGA, we have gotten a letter confirming that composite diamond coating conforms to the rules of golf. And that would be something that's easy to maintain because of the control over the very specific parameters within the coating itself.
In 1998, a carbide insert wedge was used to win all 4 majors. The most well-known wedge was Carbide Golf. Can you talk a little bit about how your composite diamond coating technology is different than that of Carbide Golf?
The key differences with composite diamond coating is that we're using genuine diamond particles, which are much harder. They're also of a shape where the particles themselves are not going to splinter the way carbide particles can. And instead of being in a soft bronze insert where the carbide particles are impregnated in, we're putting the diamond into a very hard nickel and phosphorus alloy that is coated onto the golf club. It could, of course, be coated onto inserts that are then put onto golf clubs, but either way, it's a much harder alloy that conforms perfectly to the shape of the grooves and has a defined roughness. So it's much more wear resistant, it's much more consistent.
The first diamond-coated wedge was introduced in 1999 called Pure Spin, and it became the #1 wedge on the senior tour. Pure Spin wedges later became non-conforming. Can you talk a little bit about how your composite diamond coating is different from that of Pure Spin?
The difference is whether electricity is used in the process of making the chemical coating go onto the base material or not. There's called electroplating and electroless plating. The Pure Spin coating was made with what's called electroplating. That's a technology that's been around for probably more than a century, and it's used for chrome plating of car bumpers and kitchen faucets and doorknobs and lots of industrial applications where it is suitable, where the coating doesn't need to be uniform in thickness across the entire shape, and that's fine for those applications. But in the type of intricate machinery parts and devices that we've been coating here for decades, from medical and dental to automotive and aerospace, precision of the coating thickness is absolutely essential. And that's why we have developed what's called an electroless process that's just strictly a chemical reaction to cause the nickel alloy to go onto the base metal, in this case a golf club. And so I believe that the issue with the conformity of the Pure Spin grooves to USGS standards was about the geometry of the grooves themselves. It had nothing to do with the coating or the technology of the coating. It had nothing to do with the use of diamond as we use in our composite diamond coating. It was strictly about the geometry of the grooves themselves, and if we apply our composite diamond coating onto golf clubs where the grooves are conformal, they will remain conformal even after the coating is applied. They'll remain conformal, but just have much higher performance.
A company called Liquid Metal Golf introduced irons that 25 years ago retailed for $2,000. They were made of zirconium, which has a much higher energy transfer than titanium. How's your technology similar to that of liquid metal?
Well, the objective is the same, and fortunately we can accomplish it without the incredible price tag that was associated with the liquid metal material. And the process that we use with composite diamond coating, it's an industrial process that's infinitely scalable. We do it in our factory every day of the week, so it's used in a lot of industries that are very price sensitive. So it is a reasonable way to put a surface onto a golf club as well that is focused on energy transfer. So when you're looking at coating woods and irons, the objective is energy transfer. And diamond obviously is the hardest material known to mankind, and we tested this initially with very simple tests. We would take two panels, both the same steel, but one with our diamond coating and one not, and under time-lapse photography, we measured the rebound height of golf balls off of each of those panels, and we saw a 4 to 7% increase in the rebound height of the golf balls coming off of the panels that were enhanced with composite diamond coating. We then did the same sort of work with a very controlled experiment with robotic testing for the golf clubs that had the same swing weight, the same club length, the same loft angle. Everything was exactly the same, except one club was enhanced with the composite diamond coating, and we measured in this laboratory test on a fairway an increase of about 7% farther distance. And it's because of the energy transfer that you get when the golf ball is hit by a golf club in a fraction of a second. So that actual physics is incredibly important, and fortunately something that with composite diamond coating and the hardness of the diamond is able to affect in a very real way, from real tests on golf balls and golf clubs to just seeing it in a laboratory test to confirm the basic physics of this.
I hope you have enjoyed this video as much as I have enjoyed making it. I have included Surface Technologies' contact information at the end if you would like to learn more about composite diamond coating.